Everyone, in this video we solve example 3.8 from the book Applied Thermodynamics, McConkey and Eastop. Here is the statement of the example 8 from chapter 3. A gas turbine receives gases from the combustion chamber at 7 bar and 650 centigrade at a velocity of 9 meter per second. The gases leave the turbine at 1 bar with velocity of 45 meter per second. Assume that the expansion is adiabatic and reversible in the ideal case. Or calculate the power output per unit mass flow rate. For the gases stack, gamma value is 1.333 and Cp value is 1.11 kilojoule per kg Kelvin. If there is a gas turbine, there must be some expansion taking place, and it already clearly mentioned in the statement. The expansion is adiabatic process. We already know that the pressure at the inlet will be high as compared to the pressures at the outlet. So the inlet pressure is P1, that is 7 bar. Also the inlet temperatures will be higher than the outlet, and the T1 temperature is 650 centigrade in Kelvin. The inlet velocity C1, that is 9 meter per second. The outlet pressures, that is P2, and it is 1 bar. As you can see that the inlet pressure is high and the outlet pressure is low. Gas expansion in turbine is taken place. Then the exit velocity C2 is 45 meter per second. We need to calculate the power output per unit mass flow rate of the turbine. The gamma value is 1.333. The Cp value is 1.11 kilojoule per kg Kelvin. This is, let's say, the gas turbine. These are the inlet conditions. This is the inlet of the gas turbine. This is the outlet of the gas turbine. At the inlet of the gas turbine, the pressure P1 and temperature T1 was very high. As adiabatic expansion is taken place, then the pressures P2 and temperature T2 drops, and the turbine will give you the power out the shaft of the turbine. If I draw its PV diagram, there is adiabatic expansion in the gas turbine is taken place, then there must be drop in pressure and temperatures from 1 to 2, and the expansion follow the law PV, and the expansion follow the law PV. The power gamma is equal to constant. Here the pressure is P1, volume is V1, here the volume is V2, and the pressure drops to P2. Now come toward its solution. This is adiabatic expansion. So in adiabatic expansion, the relationship between temperature and pressure, since there is adiabatic expansion, then the relationship between temperature and pressure, as we know, is rearrange this equation for T2. Now just simply put the corresponding values in it. Let me solve this on calculator. So this P2 divided P1 ratios and to the powers of gamma minus 1 divided by gamma value. When I solve this on calculators, it gives you the final values of 0.615. 923 multiply 0.615. So just simply multiply this T1 value with this pressure ratio, and you will get B2 value, and it is 567.7 Kelvin. Now apply the sturdy flow energy equation on this gas turbine. M dot C1 square divided by 2 plus heat supplied or rejected plus power input or output is equal to M dot H2 plus M dot C2 square divided by 2. Now take the mass flow rate is 1 kg per second, and also remember this is adiabatic process. In adiabatic process, neither heat in neither heat out, so it must be 0. So our final expression for power output of the turbine is equal to also the change in enthalpy is equal to Cp change in temperature, that is T2 minus T1 plus half of 2 square minus C1 square. Now just simply enter the value. What is Cp value? That is 1.11. Final temperature, that is 567.7. C2 velocity is exit gas velocity is 45 square. Then inlet velocity is 9, and remember this whole terms is in kilo, so we will must convert these terms into kilo also, so that's why we will divide it with 1000. After solving on this on calculators, you will get the power output of the turbine value, and it is, after solving this on calculator, this term will give you minus 394.4 kilo plus this term will give you 0.97 kilo. The final power output of the turbine will give you, that is minus 393.4 kilowatt. This negative sign mean that work output is obtained during the adiabatic expansions of gas in the turbine. And this is our final answer. I hope you understand. If still there is any confusion, you can ask in the comment section. Please subscribe my channel if you haven't subscribed, and also share with your friends and colleagues. Thank you so much.